Now let's have a look at question number 3 in the paper. State the factors on which the following depends. The quality of sound, and second one, the pitch of sound. So quality or timbre of sound, as you all know, depends on the waveform, that is the shape of the wave, which in turn depends on the number of subsidiary vibrations that are superimposed on the primary or the main note. Whereas the pitch of a sound depends on the frequency of the sound. So basically pitch is a subjective property of sound related to its frequency, whereas quality or timbre of sound is dependent on the shape of the wave or the waveform. The next question, give reason why hot water bottles are used for fermentation. Here the question is trying to ask you, why is hot water preferred over other liquids in bottles for fermentation? So the answer is very simple, that water is a good reservoir of heat due to its high SHC, that is the specific heat capacity. As a consequence, water once heated takes very long time to cool down. And this ability of water to liberate a large amount of heat for a small fall in temperature is made use of in this process. Now have a look at this diagram out here. There are three forces acting on this particular circular object, which is pivoted at a point O out here. We need to calculate the resultant moment on this particular object about this pivot O. So first of all, the 60 Newton force and the 20 Newton force are trying to turn this object anti-clockwise about O, and hence I can say that the anti-clockwise moment is 60 into 1 plus 20 into 2, which makes it 60 plus 40, which is 100 Newton meter. Whereas the clockwise moment is 40 into 3, that is 120 Newton meter. So now as we can see, clockwise moment is greater than anti-clockwise moment, and as a consequence this object is going to turn clockwise, and the net moment or the resultant moment can be written as clockwise moment minus anti-clockwise moment. The clockwise moment being 120, anti-clockwise being 100, so it is 20 Newton meters. So overall this object will turn clockwise with a moment of 20 Newton meters. The next question, a metal ball requires 500 joules of heat energy to raise its temperature from 10 degrees Celsius to 19 degrees Celsius. So therefore the change in temperature out here is 19 minus 10, that is equal to 9 degrees Celsius. Calculate the thermal capacity of the metal ball. So we need to calculate the heat capacity or the thermal capacity. So we know the formula that heat is equal to heat capacity into change in temperature. The heat provided to the metal ball is 5400 joules. The heat capacity is what we don't know, we need to calculate that, and the value of theta, as I told you all, is 19 minus 10, that is 9 degrees Celsius. So therefore heat capacity will turn out to be 5400 divided by 9, and that is equal to 600 joules per degree Celsius or 600 joules per Kelvin. The next question, what happens to the kinetic energy of a body when its mass is doubled at constant velocity? And second one, its velocity is doubled at constant mass. So for the first part, the mass is doubled, so we can say m2 is 2 times m1, and we can always write initial kinetic energy Ke1 as half m1 v1 square, and the new kinetic energy Ke2 as half m2 v2 square. However, it should also be realized that the velocity is constant, so v1 is equal to v2, and therefore kinetic energy 2 can be written as half m2. We wrote out here, this is 2 times m1, and v2 is same as v1, and therefore what we'll get is 2m1 into v1 square, or 2 times half m1 v1 square, which is equal to 2 times Ke1. So I can conclude out here that Ke2 is double of Ke1. So Ke in such a case has doubled. However, let's have a look at case 2. Velocity is doubled, whereas the mass is constant. So in such a case, we can say Ke2, which is half m2 v2 square, as half m1 into, instead of v2 we'll have to substitute 2 times v1, so 2v1 the whole square. So that becomes half m1 into 4v1 square, and if we take out 4, and if you write this 4 first, then I can always express it as 4 into half m1 v1 square. Now half m1 v1 square is nothing but Ke1. So as a consequence, we'll substitute this as Ke1 and conclude that Ke in such a case has quadrupled. So basically, if you double the velocity, keeping the mass the same, the kinetic energy is going to get quadrupled.